While making this quadcopter, one of the most tedious tasks that I was faced with was PID tuning. And this step is very important because it could make and break your quadcopter. So it was very frustrating here because every time I had to change one small value, I had to connect a cable from this ESP32 to my computer, do some change, and then re-upload the code. So this step would be a very iterative process, and it would consume a lot of time. So in order to counteract this, I came up with a solution where I can create a web server on the computer. So this is my local web server, and I have to connect to one of the Wi-Fi, and the same Wi-Fi my ESP32 should connect. And through that, what I can do is whatever changes I make in the PID, if I click the submit button, this goes and gets stores in here. So any small changes I have to do, I just do here wirelessly, and voila, it's done. So this is a really good step if you want to tune your quadcopter max, like to the with very much more efficiency and without wasting any time. So for test purpose, I have increased the gain on my quadcopter. So pitch and roll P gain is being increased, and now I'm just uploading it by clicking on the submit button and pressing this button on my controller, and you can see that my throttle stick is also low. I'll tell you why this is the reason. Now once that is done, I'm just gonna start the quadcopter. Boom, it crashed, and you can see that there were very much oscillations. Now I've taken that feedback and I've added these new PID values. Hopefully it's gonna be better. One thing you have to notice that I didn't use any cable here. I've just loaded the values now. You can see that it is not haphazardly just oscillating or not overshooting. Maybe the D is not that, I gain is not that well, but you can see that this is much better than the previous result. So I'll just briefly explain you how you can get it started with this. So first thing is you go to the link that I've pasted, that is of my GitHub, and on my GitHub there would be one file which would state angle mode flight controller PID values tuning. So you just have to download this file, and I've opened it here. So initially you have to add some libraries. Then you have to declare the name of your Wi-Fi. So you must be having a Wi-Fi at home, or you can use any hotspot from your mobile. So after that there are 7 actually. So first 3 are for the PID gains of pitch and roll, and the second 3 are for the PID gains of yaw, and the last variable is the time cycle. Now this is a computation time cycle, that is it like in this time one calculation takes place of the entire quadcopter. So I'll show this thing later. So after this you have like an HTML code. Now this HTML code that you're seeing here, that is from start till end, it is nothing but this. Okay, so this is the entire HTML code. I've just pasted it here, and there are certain variables and certain script functions that you can refer to, basically translating whatever is going on here into the Arduino code or into the web server, and then taking the data from the web server. So there are 2 functions here which are important. One is the read file and the write file. The write file I'll explain first. So whatever you write here, whatever value I'm writing here, like if I've written 7, and when I click on submit, the write file function is called as per, there are other processor functions there. So when this 7 is written, it is gone inside one file, and that file name you can decide. So that file name will be a text, the file type would be a text, and inside there will be the value 7, which you can extract for other purposes. And read file is nothing but reading whatever is inside the file. So these 2 functions, and this is a processor function. Basically it is pretty simple. It is just like a switch case, you can say. So coming towards the setup code, here you basically check if SPIFFF is there or not, if it's working properly, and then you sort of establish the Wi-Fi connection. Here it will print out a local IP address. So this IP address, if you paste it on any of the devices which is connected to this Wi-Fi, then you will get a page like this. So this is the page that I had shown earlier. So this is connected to this this IP address. So if you paste this IP address on any of the devices on this network, you will see this page. So coming towards an important part, so this is basically to get this function is basically to get the input message. So it is also attached to one of the variables such as param, pgain, igain, pyaw, iaw. Okay, so something so basically this is nothing but whatever data is putting entered here, it is being written into a file. Okay, so if I put anything here, this will be written in the pgain. So if I write anything here, if I let's say 8, this is getting written in the pgain. Okay, so here's the write file function that we had come across. So this is for all the variables, and then we'll move towards the loop code. So the loop code is basically from here to here. It's a pretty small code, and you can see that the t variable is here. So this is your time, and this is written in it is multiplied by microseconds. So our time is in seconds, you multiplied by microseconds. So the thing here is that this time is basically how much this the time that we tell is basically time taken for one proper computation of this loop. Okay, so the time it takes to execute one loop. Okay, that is our t. Now it is better to have very less time, but it then again depends on the sensors, because your sensors may not be that accurate or that fast to send you that data. So usually the time that people use is 0.004 seconds, but I have experimented with 0.01, 0.008, which is sort of like double. Those give me better readings because ESP32 is not that powerful. So coming towards the last part, that is this. So here you can see that receiver value 2 and receiver value 4. So receiver value 2 is my throttle stick. Okay, so basically it says if my throttle stick is very low and my this button, receiver 4 is my this button is down, then you go in this code where my variables p roll my variables p roll is reading the file pgain. Similarly, I roll, d roll are reading these files, and yaw and time. And so I'm just updating these variables using this code. And the reason why I put this is because I don't want the ESP32 being burdened by reading the file every time. So when I do this, it reads the file, it stores the variable, and that's it. And when I do this up, it is then not the code is not going through here, because this condition is false. So this is pretty much it, and using that you can tune your quadcopter or maybe any robotic device, or maybe a robotic arm or a pendulum. You can calculate and you can achieve a good result. I've added the files in my GitHub. If there's any questions or if there's any suggestions, you can leave them in the comments, or you can reach out to me on LinkedIn. Thank you if you're watching till here. If you want to see a proper breakdown of the flight controller code, then I think if this video gets like a significant amount of likes, maybe like 300 I would say, then I would do a flight controller code explanation video. Other than that, if there's anything that is required, please leave them in the comments. And thank you so much for watching, and have a nice day.